In this example, it states a sample of 35 homes in St. Catharines was found to have an average price of $382,500 with a standard deviation of $6,500. A sample of 45 homes in Niagara Falls was found to have an average price of $385,500 with a standard deviation of $5,500. Is there enough evidence to show that the price of homes in Niagara Falls is greater than the price of homes in St. Catharines? So once again, we're going to compare the mean of these two cities. And first thing we're going to do is state the hypotheses. Now, you'll see that there is some direction that is indicated here. So when we write our hypotheses, we have to make sure that we account for the order. Okay, so in this case here, what we're saying is there enough evidence to show that the price of homes in Niagara Falls, the average price for Niagara Falls, is greater than? So the greater than goes in the alternative hypothesis, and greater than that of St. Catharines, and that would mean the null hypothesis is less than or equal to the mean of St. Catharines. So there's our first step. Second step, we're going to look at the critical values. And so you can see in this case that since direction is shown, this is going to be a right tail greater than a right tail. It's pointing to the right. And so our normal curve looks up like this, with a right tail and the mean, of course, in the center once again. But this is the rejection region, and we have to look at the alpha. Alpha is 0.05. Okay, so the area here is 0.05. That would mean that this is 0.4500. And once again, let's go take a look at the z-score, or the z-table, to figure out what the value is. So 0.4500 is in between these two, and I'm going to go with the larger of the two values. Okay, so I'm going with this value, and 1.65 is the value for our critical value. So Z is 1.65. Next, we're going to perform the z-score, and once again, we are going to fill in the following formula. Okay, and that's all over the standard deviation for Niagara Falls squared, in other words, known as the variance, divided by the size of the sample for Niagara Falls, plus the standard deviation for St. Catharines. I'll just squared, all divided by the sample size for St. Catharines. Based on our figures, you should have the following. And when we solve further, I'm going to ask you to pause the video and see what you get. I'm not going to put as much detail into the calculation, but I will show what the denominator works out to be, unrounded, and then give you the z-score afterwards. So pause the video, see what you come up with, and then we'll compare notes. In the end, I have the following. 2.19 when you round. You could check the detail, but I do suggest doing this calculation twice just to make sure. But 2.19 is the z-score I came up with. And once again, I'm going to plot that onto the curve. So 2.19 ends up being, well, it looks like it's going to be far off into our rejection region. So it's somewhere here. So here's our test value, 2.19. And so you can see then our decision is to reject H naught, our null hypothesis. So once again, what does that mean? We're going to reject this statement, and we're not going to reject H1. In other words, there is enough evidence to show that the mean of the price of homes in Niagara Falls is significantly greater than those of St. Catharines. So let's state our conclusion, and I'll put that right there. So the final statement I came up with is our sample data indicates population mean house prices in Niagara Falls is significantly greater than the mean house prices of St. Catharines. With that said, we'll try the next example.